Hi, I'm Keith Petersen. I'm a principal with the E.T. Petersen Company in Westfield, New Jersey. We've been in business locally here almost 60 years. Our core original business is the vacuum cleaner business. We've added high-quality product lines, other categories of merchandise as we've gone down the road. We'd like to expose you to a little primer on vacuum cleaner technology and design so that rather than focus on specific products, we can help you to understand what makes a good vacuum cleaner a good vacuum cleaner. And we think that the knowledge that we can provide to you will result in you being able to select the proper product. We also would reiterate that you get what you pay for. We think if you buy properly, you buy right, you buy once, you'll be completely satisfied. Now, when we first started in this business, it was possible to buy a machine for $100, say a Hoover upright, and have that product for 15 or 20 years. Today, that's impossible. The vacuum industry is broken essentially into two types of machines, either quality or something that's far less than that. And we find that the best equipment pays because it lasts longer. It's the old adage, you get what you pay for. So the biggest selling machines in the quality end of the spectrum are the Italian and German vacuums, and more or less the preponderant number of vacuums today are made in China, the average life being a year or two. So that would serve as a little backdrop to what I'm going to say next, which is you need to understand the way a vacuum works and cleans and what is involved in a quality vacuum. There are 2 or 3 functions in a vacuum that will affect cleaning. Airflow and suction are one function, they're tied together, and the last is agitation. Now, if you take a dust brush and you dust a tabletop, you have a certain specified amount of airflow and suction, and the dusting action, the bristles, are supplying agitation. When you clean other surfaces, specific tools provide the agitation. When you clean a carpet, which is typically the most difficult area of the house to clean properly, you are using agitation, airflow, and suction to arrive at a finished result. It's important also to understand that in this process of vacuuming, you are removing immense numbers of very small particles in the hundreds of millions per minute. The dust mite allergens, the bacteria, the pollens, the molds, the spores are being removed from the house. The intent is to remove them effectively and keep them in the machine. And the only way to keep them in the machine is if the housings, the component parts of the vacuum, are engineered to airtight levels. If they're not, the pressure in the machine when it's operating will force the small particles out. Now, you cannot see these particles, but they will be coming out. So in the vacuum industry, there's an apprehension generally that most vacuums are very much the same. There's perhaps small differences, but that's not true. The quality of vacuums varies tremendously. The most important end result of a good vacuum cleaner is not only to remove particles out of the house, allergens if you will, but to retain them inside the machine. Now, the only way that can be accomplished is if the vacuum cleaner itself, in its design and construction, has airtight housings and passageways to prevent leakage from the vacuum. So the very best machines in that regard are made in Italy and Germany today. Most vacuums, the old-fashioned American machines, Hoovers, Eurekas, Bissells, Dirt Devils, and so on, are made in China, and those airtight levels are not achieved. So this is an important backdrop to selecting a vacuum, is to understand that the particle containment is probably the biggest part of the immediate result needed. The other thing is how well the machine cleans, how easy is it to use, how long will it last, the noise level, and so on. So without saying much more, I'd like to give you a little detail here on the way vacuums work to help you understand, and then you can intelligently make a selection as to the machine that you think is best for you. When a vacuum is functioning, there are 3 elements involved in the cleaning process: airflow and suction, which are tied together, and agitation. The airflow and the suction is provided by the motor fan or fans, and there's a couple different types of motors used in this business in residential vacuums, and I'll explain that. And then the agitation is provided by the tool that's used at that point. If you're dusting a tabletop, The dust brush bristles are providing agitation. If you're cleaning a bare floor, the bristles on that nozzle are helping to provide agitation. The hardest section of the house to be cleaned would be the carpet in most instances. And a carpet is cleaned with 3 different types of nozzles today. Either a traditional, if you will, old-fashioned rug nozzle. There are no revolving bristles at all. The tool is moved back and forth over the carpeted surface. The airflow and the suction do the majority of the cleaning. There are generally some sort of pickers or device on the bottom of the nozzle to help break the surface friction and remove material. Then we have tools where the brush revolves, and those come in 2 types. Turbo tools, which work off the airflow that enters the tool, and then motorized or electric brushes, which is the preferred way to clean. For residential use, the average hose is approximately 1 inch or 1.25 inches in diameter. That allows the main motor to provide the necessary suction and airflow to whatever the cleaning process that you need to achieve. In the commercial field, vacuum hoses will go up to 3 inch, some even bigger, but the average is 1.5 inches. The problem with that for residential use is the hose gets a little bulky. The advantage is it helps enhance the airflow and the cleaning ability. Now, when you spin a brush in a machine, these are a couple of standardized brushes that would be used in products in this industry. It's important to understand that the action of the brush is to surface comb the tips of the carpet. Many people, even in this industry, think that bristles reach down in and comb deeply embedded dirt up to the surface. They never do that under any circumstances. They are combing the tips. And if you look at the bristle on a brush, you'll see it's relatively short. And once the brush is set into a housing, that bristle is just meeting or exceeding the bottom of the intake of the housing. So it's a surface grooming tool. It's an assist to the process. But the key to deep cleaning a carpet is to have plenty of airflow and suction. Now, some believe that airflow is the most important part of the equation, but there's a link between the airflow and the suction, and both are needed. A very good example is if one were trying to clean powdered sugar off a table. That product, that material, is extremely lightweight. The surface has very little tension to it. It's a flat table. Airflow really would be all that's needed to remove that powdered sugar and bring it back to the container. If we were trying to dig sludge out of a production pit in a manufacturing facility, we would need lots and lots of suction to lift it, and then the airflow is necessary to help carry it back to the container, whichever container it is. So it's the melding of those 2 processes that achieves proper vacuuming. So a brush is combing the tips, the airflow and the suction is deep cleaning the carpet. So the apertures we mentioned before are important because we want to maximize that type of airflow. Now, this is a turbine brush. It's a small one. It's used typically for upholstery. The industry makes turbine brushes for cleaning rugs. Many manufacturers will offer them as options in their cleaning equipment. The nature of a turbine brush, and it would be difficult to see this, but you can trust me when I say that this intake, where my small finger is, narrows down to roughly 1/2 inch. The reason for that is to speed up the air as it goes across a turbine fan, to make that fan spin at high speed, and therefore make the brush spin at a usable speed. The mischief is that deep cleaning airflow that's needed to air wash through the carpet and get those particles out from the depth of the carpet is being stolen to make a brush spin, and the brush is only combing the tips. So if you use a turbine brush on an average carpet, especially if it's thicker or longer, you are not going to effectively deep clean that carpet. In distinction, if you look at an electrified brush, the intake on the brush is huge, coming all the way across and back, and keeping that 1 or 1.25 inch opening so that the airflow can have its effect. There's a motor in the tool which spins the brush. And by the way, you can see what I was saying before, that the bristles on a brush are just about hitting the intake of the nozzle. So it's a surface cleaning tool. So that high airflow is very important. We don't recommend that you use turbine brushes. Once the particles are in the vacuum, as highlighted before, you need to keep them in the machine. You need those airtight seals. The air has to leave at some point, so you need to contain as many particles as they come into the machine as possible, and that's accomplished in 2 or 3 different ways. The first is the bagging mechanism that's in the machine. At our facility, we don't sell bagless vacuums. You have eliminated the first mechanism to capture particles. The vacuum is assailed with fine particles, and you cannot properly empty the machine with any degree of being sanitary. The particles are flying all over the place. So a bag is a necessity. Now here's an average industry standard bag. If I shone a flashlight through this bag, you could see it coming out the other side. These are traditional bags. They will contain only the larger particles. Bags, then, we march through bag design, we might say. When you hit a properly designed bag, this is a bag from Miele, which is a German vacuum cleaner. There are 9 layers of filtration in this bag. Its function is to capture particles well, to keep as many as possible, therefore, in the bag, but yet allow the airflow to come properly through so you can continue to clean. So the design of a bag is extremely important. Then after the bag, there's typically a secondary filter, and then the final filter on the vacuum is what determines the final air quality in connection with this airtight design. So that final filter is very important. The industry uses the term HEPA or HEPA-like in an extremely casual manner. This is a filter that the industry would term a HEPA filter. And if we get a close-up of this at some point, you'll see it's a very rudimentary design. The filter mechanism itself, the entire cartridge is not airtight. When you get into a high-grade filter, this again is a Miele filter, this filter is completely sealed. If you tried to take this apart with a screwdriver, it would probably take you 10 or 15 minutes. It's a certified S-class HEPA filter, and it has a gasket, and when it fits into the compartment in which it resides, there's no air bypass. Everything has to go through the filter. By definition, everything to bacteria size is removed. So this is extremely important. Then as a recap, we need to be able to vacuum effectively. We have agitation, and I should take an aside and mention that if your product is using a spinning brush, there are 2 types of belts. Typical stretch rubber belts, which needs replacement, and then a cogged belt, a timing belt, if you will. It has teeth, it doesn't stretch. The brush is always spun at a proper speed, and if you typically jam the product, you pick up a t-shirt under a bed. Most of those designs involve the tool shutting down, the brush shutting down in its action, and it protects the belt. You may never replace the belt. So that agitation design is important. This, by the way, is a power brush motor. You can see it's small. Its function is simply to spin the brush. As we get into suction motors, they vary. This is a small, compact, but very high efficiency suction motor. This again is out of a Miele vacuum, a German machine. This is a standard twin fan suction motor made in this country by the Amatec Lamb people. This type of motor would be used in many different vacuums in this industry. You can see it's larger and heavier. Motors come 1 fan, 2 fans, and 3 fans. The more fans, the more cleaning efficiency. When we get into commercial products, the motors get bigger because the larger the fan chamber, the more air is brought through the machine. In a domestic pull-around vacuum, this type of motor would be too big and too heavy. So the standard sized motors in vacuums in canister and upright machines are in this range. This is the standard size for a power tool. These are the types of brushes, the belts, the airflow I've discussed, the filtration. All this results in a machine that will give you the proper cleaning efficiency and keep the particles inside the vacuum. So when you choose a vacuum cleaner, these are the things that need to be in the forefront. We think that if you buy right, you buy once, you'll be totally pleased with the product, and you can call us here at the E.T. Petersen Company for suggestions or advice Our phone is 908-232-5723. Thanks for watching.